Hi, are you ready for some anatomy help? So I know it can be a little challenging with all the histology. Remember, histology, the study of tissues, and we're looking on a microscopic level, and that can be problematic for some people in identifying what type of tissue we're actually looking at. So we're going to go through some of the types of slides that you would be responsible for knowing and hopefully helps a little bit in remembering. Okay, so we're going to start. All right, first we have, okay, squamous epithelial tissue. And this first image right here shows simple squamous. So remember, squamous are those flat, irregular kind of cells. And you can see one single layer of cells surrounding the interior of this blood vessel. Okay? But you can also have stratified squamous. And look at all these layers. So this is cutaneous membrane, your skin. And you can see all of these flat cells in many layers, so stratified squamous. And you can see here evidence that these layers are going to peel off, which is how you can tell it's the cutaneous membrane or your skin. Now let's look at cuboidal, okay? And you can see right here, this layer is a single layer of cuboidal cells. Here we go, a single layer of cuboidal cells. So this would be simple cuboidal. And here we have two layers. So it doesn't matter if I have and how many I have, as long as it's more than one. So this would be stratified cuboidal epithelial tissue. Simple, stratified, both cuboidal. All right, now what about columnar? So columnar, remember those tall, thin like columns? So here is a layer of one layer of columnar cells. So this would be simple columnar. And here we can see multiple, we have two layers. So this is stratified columnar epithelium. So both columnar, but this one is simple and this one is stratified. Now, pseudostratified means every single one of these cells comes down and touches this basement membrane, but they sort of have this irregular appearance. So it seems as though there's multiple layers, but it's not. Here is the one red flag that'll usually tell you it's pseudostratified because you see the cilia on top. Okay, so this is pseudostratified because even though it's irregular looking, each one of these cells comes down and touches the basement membrane. Now, skeletal muscle. Here is a cross section. Okay, so imagine in my arm right here, I would cut through like this, okay, and seeing the different bundles of muscle fibers. This view is one that you're going to see more often, showing the striations, the stripes, okay, and often you can see the nuclei are sort of lined up between where those bundles would be. So you can see in this one, you see the nuclei usually at the edge of the bundles, not in the center. So I'm going to see the same thing here in skeletal muscle, but the key is these very clear striations. Cardiac muscle tissue. I still have some striations, although typically they're less evident than skeletal muscle. And I'm going to see often some space in between as they're interconnected, because here, right here, these lines represent intercalated discs. And these allow cardiac muscle cells to communicate rapidly with each other to allow contraction of the heart rhythmically. Okay. Now, smooth muscle tissue, no striations. Okay. You see this sort of flattened nuclei, and you're going to see these close together. And there's not usually this wavy appearance, okay, that you'll see with a type of connective tissue. So again, smooth muscle is no striations. We have these flattened nuclei. And again, there won't be clear evident waves. Loose connective tissue. So I see fibers. Those are these. I'm going to see fibers or strands. And then I'm going to see nuclei, and I'm going to have a lot of matrix. So when you can see evidence of cells and fibers, and then there's a lot of space. So think loose connective tissue. Dense connective tissue, on the other hand, do you notice how it tends to be a little bit wavy? Okay, this is a lot of fibers, but packed tighter together. So again, this is loose connective compared to dense connective. A lot more packed in dense connective. This is an example of adipose tissue, which is a type of loose connective tissue. I always look for these, what seems to be big empty spaces. These are the nuclei. Okay, these are not actually empty spaces. They would be filled with fat. Okay, but there's the hint. It looks like these big empty cells. Blood tissue. So I have a lot of these red blood cells, and then I have these larger cells, which are white blood cells, and then I have these small little specks, which are little pieces, not actually cells, but those are platelets that help with clotting. And then what would be white in this picture is the plasma, okay, the liquid, the matrix part of blood. Bone tissue. The only kind of bone tissue I'm going to ask you to remember is the kind that looks like tree rings. So we have the center piece and then what looks like tree rings circling out from that center part. We will talk more about this structure when we do the skeletal system, but this is how you would identify bone tissue. And then cartilage. Okay, I always think about cartilage like it looks like you have these sort of spaceships suspended in this fluid or liquid, although it's a little bit more durable than that in the matrix. But I always look for these like spaceship looking cells suspended. Okay. There are other types of cartilage, but in general, I just want you to know cartilage. So we're looking for these spaceship looking cells, okay, suspended in this matrix. And then we have nervous tissue. Remember with the stars of the show, the neurons, okay? But with a huge supporting team. Look at all of these glial cells or neuroglial cells. Okay, these are like the makeup, the hairstylist, all the things allowing the neurons, the stars of the show, to do their job. Okay, so nervous tissue, you're going to see neurons, but a lot more glial cells, a lot more supporting cells, and those are much smaller. Okay, so there you have it, a quick overview of how to interpret some histology slides.